Greetings. My name is Alex Busetta. I'm a consultant at Abacus team as well as a adjunct professor at McGill University. And welcome to this session on process capability. And we will be discussing about Cpk and Ppk. And we're going to go a little bit deeper than the usual notions that are being taught to green belts and going to more black belt if you prefer in terms of notions. You have my email below on this page if you'd like to reach out to me. So first of all, before starting any type of process capability, we need to understand what are the specification limits, what is the minimum and maximum, or sometimes just a minimum or a maximum given by the customers. And just as a refresh, what are the formulas for Cpk? And the formulas are not that important. Understanding is much more important than the formulas. So in the Cpk, which is the real process capability, we're trying to see what is the distance between the average and the lower specification limit divided by 3 times the standard deviation. And we do the same thing for the upper specification. And then we're taking the lowest value and gives us an index in terms of how capable we are to meet the customer's specification. And the higher, the better. CP is a measure of the potential capability. So we're not really looking at are we meeting, but our potential. How much variation do we have, and do we have a variation problem or not? So the higher the CP, the better it is, meaning our distribution is very narrow. So what does Six Sigma look like? So we have the average and we have 6 standard deviations on each side to the specification limits. So when you think about it, Six Sigma in reality is 12 standard deviations from the lower to the upper specification. And long term, what we call Ppk, we do have typically a shift, as you see on that slide. So a little bit more terrain wear or degradation in terms of our performance. Think about summer vacations, new employees that are leaving, new suppliers, new system. So we will see typically more variation. So here is an example, and this is typically what we teach in terms of the green belt training. And what we teach over there is that if we have a certain sigma level short term, we can, of course, convert it to Cpk. So if you look at here, the numbers, sigma level short term is 3 times Cpk. So Cpk of 2, which is 6 sigma, Cpk times of 2 times 3 gives us a sigma level of 6. And if we're looking at long term, so the performance over a year or more, it's 3 times what we call Ppk. So Ppk being bluntly the same thing as Ppk, but as a Cpk, but long term. So what we typically see in books, including in most green belt training, is that the Ppk, so the long term, is Cpk minus 0.5. So take your level of Cpk, like you see in this example here, we have a waiting time in minutes and our Cpk is quite low. So minus 0.18. So we subtract 0.5 and we get to the Ppk. So let's not forget that Cpk, Ppk, sigma levels, green belts, black belts would understand these notions. For the common mortal, your colleagues, your partners, your managers use a percentage. And if you see in this example here, we can say that the yield short term, so the success rate short term is 29.5 5%, which is not very good, right? It means that we have roughly 71% of defects in that situation. So this is what we typically see. So calculate your CPK and calculate your long-term by subtracting 0.5. If you prefer, if you look at the sigma level, it means take your sigma level short-term and reduce by 3 times 0.5, so 1.5. Let's go, though, a little bit deeper than this basic notion, because the shift of 0.5 is really based on studies that were conducted by Motorola, and they might not apply to any other organization. It is a good estimate, a good average, but it is an estimate. So the accurate way to get PPK, let's talk about it and we will demonstrate. First of all, we would calculate CPK based on a sample or a subgroup that we're taking a specific week or specific month. So this, we would get a CPK for a subgroup of 1. Then the next month, we're taking another data set, another sample. So we can calculate the CPK for that other subgroup. So we can do this for all different subgroups. And then what we can, of course, do is calculating the typical CPK, what would it be. So I could then calculate in terms of saying the average performance on a given month if of that much. What is much more interesting, though, is to calculate the PPK. And the PPK, you have it over here. It is the overall performance based on what we measured from 1 month to the other. So the PPK is for the entire data set. What is very interesting for PPK is that instead of just saying, well, we collected data for a year, it gives us a prediction even for the next 2 years, 3 years, 4 years. It looks at the actual shape of the distribution and tells us, well, if you overall gathered 1 million data points, this is with the performance that you would get. And this is overall what we see. And you have here an example of the different performance factors that we could get. So this is an example based on milligrams of medication, and we will demonstrate these in the Lean Six Sigma companion. So in the companion, if I go over here, I would go to the measure overall phase, histogram process capability. And let's start with a simple example where for our milligrams of medication, so we have here, let's say 90 to 105. So our pill or dosage of medication can accept a large variation from the point of view of the customer. So we see graphically that the histogram looks not perfect, but quite good. What the companion gives us over here are different metrics in terms of how good or how bad is what we see over here. So we have, first of all, the observed yield. So I'm just looking at the data that was collected. We have a data set here of 500 data points, and we observe that the overall yield is 98.8%. That's what we observed. The CPK, so the estimate, so the overall average for a given month or a week is going to be here 0.84, or we could expect a yield of 99.4%. So this is saying is, well, you just took 500 data points. If you look at a particular point in time, you can assume that you might get a performance roughly of 99.4%. And we also have the expected overall, which is PPK, meaning if we gathered millions of data points during a year, what would be our performance overall? So let's change here to something a little bit more realistic, because if this was really medication and we're supposed to have, as an example, 100 milligrams, I could have, for example, here some tolerances or limits of 98 milligrams to minimum to 102 maximum. You also have here the subgroup size. So what is the subgroup size? This is telling us, and I'll go back to this example over here, each one of the weeks or each one of the month, how many samples did we gather? Is it 5? Is it 10? Is it 100? And here in this example, we have 5. So giving this, we see here that the histogram shows that we have a much bigger problem. So just looking at the data we collected, the yield, the percentage of success is 64.4%. And now let's look at the extrapolations. So first of all, the CPK, so meaning looking at a specific month or a specific week, we could expect that we're going to get a performance of 68.6%. So taking an observation on a very short term. So now the expected overall, or what we call the long term, then we see here that the PPK is 0.29. So if you observe between CPK and PPK, there's no factor here of 0.5, like what Motorel suggested. So this is real data, and we're showing the real shift. So the shift is much lower than 0.5. And we see that long term, for example, over a year, and if we collected millions of data points, millions of data collection on those pills or that dosage, we can expect a yield, a success rate of 62.3%, which is lower over time. So it's typically lower, but we can see here that still it's not that big of a shift. Still a great opportunity for improvement over here. So this is actually what we typically look at. What is our observed in our sample that we collected, a total of 500 here. What can we expect in a given month or week? And what could we expect overall over a year if we collected more than 500 samples, but if we collected, for example, 1 million samples? I'll return to the menu, and I would like to show you something else in terms of the companion. We also have here a before, after capability analysis. And over here, we got the data before improvement and after improvement. So if you look at the histogram, this is the same one that we've seen before. So we do have problems. And after our improvements, we can see here that it is much better. So we have our 98, our 102, and we see that we quite reduced variation over here. So the companion gives you the actual performance in terms of the PPK, in terms of the entire data set in this comparison tool. I see here that my yield is much better, right? It's a sigma level of 5.23, or if you prefer PPK of 1.74. So if I added some decimals, probably it would not be 100, but 99.9999 something. And below we see the comparison. So the yield before and after, or the PPK or sigma levels if you prefer, and did we improve or not? So it gives me a very, very clear picture in terms of assessing what happened and what kind of improvement was generated. So we hope that this explanation of the real way to calculate CPK and CP was helpful for you, and please reach out if you have any questions to my email. You also have our website if you would like to take a look at the companion or any other information. Thank you very much.